Yeah, we're going to write a greatest common divisor as a linear combination of the two numbers you're trying to find the greatest common divisor of. Now, I've made a video like this already, but it was about 13 minutes. I'm going to do this a lot faster by keeping it in one screen. All the work we did to find the GCD instead of bouncing back and forth between one screen and another, I have it all copied right here. And here's the work that you do. So you never really use the last line, so I'm going to scratch that out. But here's what we do. We use the second to last line, okay, and we're going to work our way up. You always want to solve for the last non-zero remainder you have in terms of the two other numbers. And all you do is I'm gonna start. So I'm gonna take this. I'm gonna put this first, and I'm gonna write. So I'm gonna write the 14 equals 12 times 1 plus 2, but I want to solve for the remainder. I'm going to subtract the 12 times 1 on both sides. And then so I get, this is 14 minus 12 times 1 is equal to 2. Now here's why, because you want to start off. Now this is sort of like the work behind the scenes here. This is the where I'm getting the work from. So the first thing you write is 12 is equal to 14 minus 12 times 1. And because you want to do them both as linear combinations, if you want, you could also put like a times 1 right here, but really it's not necessarily it's not. But I do this to show you that we're not just pulling these numbers out of nowhere. But you're always going to keep writing a 2 each time. And here's the key. You want to eventually get to the point where you get 2 is equal to 124 times something plus or minus 110 times something. That is the end goal. But we don't know how to magically get there yet. So we're just going to keep writing. We already used this line right here to write 2 as a remainder of something else. Now, I can write 12 in terms of something else. So obviously I use this line next. So I'm going to put that right here. So all I'm doing is copying this second to like this is the last line, but we never use it. The second to last line, this third to last line, I keep working my up. And I want to solve for 12 in terms of the bigger numbers so that I can replace this 12. So I'll just subtract the 14 times 7 on both sides. So subtract 14 times 7 on each side here. And so you get 110 minus 14 times 7 is equal to 12. And I'm going to substitute for this 12 right here. So I just replace the 12 with a 110 minus 14 times 7 quantity. And so like this 12 is substituted here. And the little 1 is still there. It's not really useful since it doesn't really do anything. But all I'm doing is substitute. So I'm going to make note that since I used this already, I'm going to scratch that out. Now the next thing I do is I want to write 14 in terms of two bigger numbers. So I'm going to take this line right here. And I'm just going to copy it. And then I want to solve for 14 in terms of two bigger numbers. So subtract 110 times 1, and then subtract 110 times 1 there. And so I get that 124 minus 110 times 1 is equal to 14. Now, I skipped a step here. I don't want to go too fast. I did go a little too fast. Since I see two 14s, like it's just going to be trouble. I could substitute both of these in place of 14, but it just looks like a mess. So like I would literally be writing 124 minus 110 times 1 here, and I'll be writing another 124 times 110 times 1, and it makes it harder to clean up later. You could forget how to do it and you'd be fine as long as you replace both 14s. But just for the sake of making it look a little nice, this is really a 14 times 1, right? And this is a 14 times, if I distribute this 1, which is really, it's pointless to even have that 1. Um, there's really only 1 times 7, which is 7. So there's 7 14s, and then there's one more 14. And by the way, you might think that's a negative, but remember you got to distribute this minus. Change that to plus. Change this, the distributive property. And so we actually have 1, 8. We have 14 times 8. So there's 8 14s minus, and there's only one 110. This one's kind of useless, but I'm just going to put it just so it looks like nice linear combination stuff. And so now we can substitute, since 14 is 124 minus 110 times 1. I'm just going to keep carrying the 2 down. So replace this 14 with 124 minus 110 times 1. So that quantity, and then the 8 is still there. So this 14 is this thing right here. and then the 8 is that thing right there. And then minus, there's a 110 times 1 here. Now here's the thing, there's only the 124 here, but we got to distribute this 8 to both terms. So I should distribute the 8 like that to both the 110 times 1. That's all one term because they're connected by multiplication. And then there's, so 124 times 8. So 2 is equal to, we come out to 124 times 8 minus 110 times 8 times 1 is 8, minus another 110 times 1. Oh, wait, so altogether there are 124, there's 8 124s, and then there's negative 110, 8 of those, one more negative 110, so there's 9 of those. So your final answer is 2 as a linear combination of 110, 124 and 110 is 124 times 8 minus 110 times 9. If you just see the solution here, it's like hard to tell where this even came from. It's like, wait, where'd you get these numbers? But remember, here's the key. We work backwards from finding our GCD. We start with, you ever use the last line? We do the second to last line. We write the remainder in terms of the two bigger numbers. So all we do is isolate this 2 right here, swing this over. Do stuff, simplify. Then we isolate the 12 in terms of the two bigger numbers. Do stuff, substitute, simplify. Then we isolate the last, like the first line of the GCD work. We isolate that, substitute, simplify, and the end goal is to get this GCD written in terms of only how many 124s minus how many 110s, your two original numbers. That's it.